All right, let's get right into it. At the core of any good software design, there's this big question. How do we actually manage all the connections between the different pieces of our code? Well, today, we're going to look at two really powerful patterns that try to answer this, but in totally different ways. The factory pattern and dependency injection. It's really a battle for control, and trust me, understanding this is going to change how you look at your code.
So here's our game plan for this explainer. First, we'll tackle the main problem, what we're calling the dependency dilemma. Then, we'll check out a classic fix, the factory pattern. From there, we'll dive into a huge paradigm shift called inversion of control, which, you'll see, leads us straight to dependency injection. And finally, we'll put them head-to-head to see what the final verdict is.
Okay, first up, let's really get to the heart of the problem. In any piece of software that's even a little complex, objects don't just live on their own. Nope, they need to work together, they need to collaborate, and that right there, that creates dependencies.
And this is exactly where things get messy. When one object directly creates another object it needs, they get what we call tightly coupled. Think of it like a giant tangled web of wires. If you need to change just one wire, you could end up having to rewire the whole thing. It makes your code super fragile, a total nightmare to maintain, and testing it in isolation? Forget about it. It's a massive headache for any developer.
So, the million-dollar question is, how do we untangle this web, right? How can we give our objects the things they depend on without basically hardwiring them together? This very question leads us to our first potential solution.
So let's talk about a classic approach that's been around for a while, the factory pattern. The whole idea here is to put the job of creating objects into one central place, so you don't have object creation happening all over your code base.
And what's really key here is that word ask. Your code knows it needs something, so it goes to this central factory and requests it. It actively pulls the dependency it needs. A great example of this, if you've used Spring, is the bean factory.
The process itself is pretty simple. Your code basically says, "Hey factory, I need one of these." The factory then does all the heavy lifting. It creates the object, gives it anything it needs, and then just hands the fully formed object back to you. The crucial takeaway here is that your code is still the boss. It decides when to ask for that dependency.
But then, a huge shift happened in the world of software design. I mean, a complete flip in how people thought about this stuff. And this is the concept of inversion of control, or IOC. Honestly, this is the big aha moment. It's a foundational change that really paved the way for the massive, testable applications we build today.
And this lays it out perfectly. Traditionally, your code is in charge. It creates what it needs when it wants. But with inversion of control, that responsibility gets flipped. It's inverted. You hand over control to some external thing, like a framework. Your code just kind of raises its hand and says what it needs, and then it trusts the framework to handle the rest. The source material puts it perfectly here. When you're using a framework like Spring, the developer is no longer micromanaging the life of every object. The framework takes care of creating things, wiring them together, and managing them. This is a massive, massive change. We've gone from actively taking what we need to passively receiving it. So, if inversion of control is the big idea, the philosophy, then dependency injection, or DI, is how you actually do it. It's the practical application of that philosophy. Let's see how it works.
The key word to focus on here is injected. Instead of your code going out and pulling a dependency from a factory, the framework, the IOC container, pushes the dependency right into your object. Your object doesn't even need to know where its helpers come from. They just show up, provided or injected when the object is created.
In the world of Spring, this push can happen in a couple of main ways. You can have dependencies injected right through the object's constructor as it's being born, or you can have them added later through setter methods, and each one has its own pros and cons.
Okay, this table is super important for understanding the real-world trade-offs. Constructor injection is your go-to for mandatory dependencies. Why? Because the object literally can't even be created without them, which guarantees it's always in a valid state. Setter injection, though, gives you more wiggle room for dependencies that are optional. And here's a fun fact. It can sometimes even get you out of tricky situations like circular dependencies, where two objects need each other to exist. So, why do we bother with all this?
Well, the payoff is absolutely huge. Dependency injection gives you cleaner, loosely coupled code. And this is the big one. It makes testing a million times easier. Because dependencies are pushed in from the outside, you can easily swap in a mock or a fake dependency when you're running a test. This lets you test one piece of your code in total isolation, which is just fundamental to modern software development.
All right, the moment of truth. It's time for the final verdict. We've seen the classic pull style of the factory pattern, and we've seen the modern push style of dependency injection. Let's put them side by side and see how they stack up.
Let's just boil it all down. With the factory pattern, your code is in control. It pulls what it needs. With DI, the framework is in control. It pushes the dependencies to your code. And that simple shift in control is what makes DI so much more flexible and way easier to test, because you can inject whatever you want, the real objects in production and fake mock objects when you're testing.
And the source material really drives this point home. Look, both patterns help you untangle your code and reduce coupling, but it's pretty clear that dependency injection has come out on top as the better way to build flexible, maintainable, and highly testable applications.
So, as you go back and look at your own code, I want you to ask yourself this one simple question. Is your code actively asking for the things it needs? Or is it just declaring its needs and having them given to it? That simple question is the fundamental difference between the factory and dependency injection, and it really is the heart of this whole battle for control.